Hello everyone, welcome back to Digital Lesson for Students by Department of School Education, Nagaland. I am T. Punguri from C.D. King Higher Secondary School, Jotsama, Kohima. In the last session, we learned how to find the minors, cofactors of an element, adjoin and inverse of a matrix. In this session, we are going to learn how to solve the system of linear equations using inverse of a matrix. System of linear equations you have already studied in your lower class, in class 10, that is for only two equations with two unknowns, but here three unknowns, and which will be given by three equations. Okay, let's get started. Consider a system of linear equations as a1x plus a2y plus a3z. No, let me use different variables. b1, c1, that is equal to d1. a2x plus b2y plus c2z equal to d2, and a3x plus b3y plus c3z equal to d3. Here we are given with three linear equations. Okay, this system we can write in the form ax equal to b, right, where A is the coefficient matrix. Coefficient matrix, that is, you pick up all the coefficients from the equations and put it in this matrix, that is a1, b1, c1, and here a2, b2, c2, and this one a3, b3, c3, right. Okay, then what is this x? X is the variable matrix. What are the variables we have? X, y, z. So here you have to put it in the column matrix x, y, z, and this constants, let us take it as b, d1, d2, d3. Always keep the constants other side of the equal. We can write this form, isn't it? And now we have two cases. Since we have the matrix A, one is determinant is equal to 0 or not equal to 0, isn't it? Okay. And here, after writing the system of equations in this form Ax equal to b, we get two cases. The first one is determinant of A is non-zero and determinant of A is equal to 0. If it is non-zero, then we call it as non-singular matrix, right? Okay. Here, if it is non-zero, then we have the system as Ax equal to b. If you pre-multiply by A inverse, what do we have? A inverse Ax equal to A inverse b. Then this is A inverse into A will give us identity matrix. I into x equal to A inverse into b, right. Then I in identity matrix with any matrix will give us the same matrix x, that is equal to A inverse into b. In the last session, we learned the formula how to find the inverse of a matrix. Therefore, x equal to 1 by determinant of A into adjoin A into b. Using this formula, we can get the solution of the system of linear equations. Okay. Here, if it is non-zero, then if it is 0, the determinant is 0. Then we calculate adjoin A into b. Here also adjoin A into b. Suppose this is non-zero, it is not a zero matrix. Then if this is a zero matrix, what will happen? If this is non-zero, the system will have no solution. The system will have no solution. And if this is 0, the system will have infinitely many solutions. Infinitely many solutions, right. Here, as the inverse is unique, already we have learned the theorem, inverse of a matrix is always unique. Therefore, this gives us the unique solution. we get unique solution here, and here no solution, and here infinitely many solutions, right? Okay, here we say the system is consistent. We call the system as consistent. No solution, we call the system as inconsistent. And if it has infinitely many solutions, the system is said to be consistent. Okay, when we say that the system is consistent, if it has one solution or many solutions, isn't it? And if it has no solution, we call the system as inconsistent. Okay, I want you people to remember this chart. Okay, let's do some problems from the exercise. This is from your exercise problem. Examine the consistency of the system of equations. X plus 3y is 5 and 2x plus 6y equal to 8. Okay, here we are given two equations. Okay, let us write this given system in the form Ax equal to b, right? So where A is the coefficient matrix, then what is the coefficient here? 1, 3, 2, 6, and then x is the variable matrix. Here we have only two variables, that is x, y, and what is the b matrix? The constant matrix 5, 8, right? Okay, the first thing we have to do is to check the determinant of A. So determinant of A is 1, 3, 2, 6 will give us, cross multiply 6 minus 6, 6 minus 6. So this is 0, right? So determinant of A is 0. In that case, we have to calculate adjoin A into B, right? So let us find the adjoin first. I already told you the shortcut to find the 2 by 2 adjoin of a 2 by 2 matrix, isn't it? So we will interchange these two numbers. So it will be 6, 1, and change the sign of these two numbers. So minus 3, minus 2. This is the adjoin matrix. And then find adjoin A into B. So that will be 6 minus 3 minus 2, 1 times, what is B matrix? 5, 8. Hope you will remember the matrix multiplication. If not, you please watch the previous videos. Multiply, you take the first row and this column. So multiply element wise and add it. 6 into 5, 30, plus minus 3 into 8, minus 24, right? And take the second row and this column. Multiply element wise and add it. Minus 2 into 5, minus 10, and plus 1 into 8, 8. So which gives us 30 minus 24 will be 6, and minus 10 plus 8, that is minus 2. So this is not a 0 matrix, isn't it? So if you can remember that chart, here determinant of A is 0, but the adjoin A into B is non-zero. So how do we conclude? The system is consistent or inconsistent? The system is inconsistent. Therefore, the system is inconsistent as it has no solution. With this knowledge, you will be able to solve the remaining problems in your exercise. Okay, next we will see one important 6-mark question. Okay, every year, both in NBSE and CBSE, we will get one question for 6 mark. So let us learn that one now. The question will be like, solve the system of linear equations using matrix method. This is called matrix method. Or using inverse of a matrix. Solve the system of linear equations, using by matrix method or by using inverse of a matrix. Let me take this system: x minus y plus z equal to 4, 2x plus y minus 3z equal to 0, x plus y plus z equal to 2, right. Okay. So, the given system, let us write in the form Ax equal to B. Let us write the system as Ax equal to B. The steps are very important, no skipping steps, where A is, write the coefficients 1, minus 1, 1, and here 2, 1, minus 3, and here 1, 1, 1, right. Okay. Then write the variable matrix. What are the variables we have? X, Y, Z. And the next one is the constant matrix. What are the constants here? 4, 0, 2. Okay. The first thing, we have to find the determinant of A. So, determinant of A is 1, minus 1, 1, 2, 1, minus 3, 1, 1, 1. All right. So, how do we find out? Do you remember? Yes. So, we take 1 into, deleting this column and row, we get these 4 elements, 1, minus 3, 1, 1, isn't it? Then minus of minus 1. I am expanding through the first column. If you wish to expand through second column or third row, anything you can do it. It can be done by 6 ways. Then minus 1, then deleting the column and row, we get 2, minus 3, 1, 1, then plus here 1 into, if you delete the column and row, we get 2, 1, 1, 1, 2, 1, 1, 1. Okay. Then here again 1, you cross multiply and subtract. So, 1 minus of minus 3, right. Then minus into minus, plus 1, and here we get 2 minus of minus 3, and here plus 1 into 2 minus 1. Okay, here minus into minus plus, so 1 plus 3, 4, and here plus 5, plus 5, and here 1 into 1, 1. So, this is 10. It is not equal to 0. Therefore, A is non-singular. Therefore, A inverse exists, right. Okay. Then let us find the adjoint matrix. Remember this value 10. Then A is 1 minus 1, 1, 2, 1 minus 3, 1, 1, 1. So, let us find the cofactors first of all. A11, A12, then A13, then we get A21, A22, then A23. So, that is A31, A32, then A33. Okay. So, let us do it first. Plus into, if you take out this column and row, we get these 4 elements, right. So, 1 minus of minus 3, that is 1 plus 3, that is 4, right. Okay. And when you take this number, delete this row and column, we get 2 plus 3. So, here we introduce minus sign, right. 2 plus 3, that is minus 5. So, you will remember the signs, right. Plus, minus, plus, minus, plus, minus, plus, minus, plus, isn't it? Okay. Here 2 plus 3, and here for this element, you delete this row and column, we get this 4. So, 2 minus 1. So, that is 2 minus 1, that is 2. Okay. And for this element, we introduce minus sign. Deleting this row and column, we get minus 1, that is plus 2. Okay. For this element, delete this column and row, and we get 1 minus 1, plus of 1 minus 1, that is 0. Okay. And for this number, delete this column and row, we get 1 plus 1, 1, 1 plus 1, that is minus 2, right. And here for this number, we introduce plus, here we introduce minus, here we introduce plus. Okay. For this element, you delete this row and column, we get plus 3 minus 1. So, that is 2. and for this element delete this column and row, we get minus 3 minus 2, minus 3 minus 2, that will be 5. And for this element we delete this column and row, we get 1 plus 2, 1 plus 2, that is 3. Okay, and then let us find the adjoint matrix. So that is the transpose of this one, 4 minus 1 minus 5 2 2 0 minus 2 2 5 3. If you take the transpose, what do we get? 4 minus 5 2 2 0 minus 2 2 5 3. I think this is 1, right? Yeah, this is 1. Minus 2 3. Okay, fine. Okay, now let us find the variables x, y, z. How do you find x? X equal to A inverse B, that is 1 by determinant of A into adjoin A into B, right? Okay, so 1 by determinant value is 10 and adjoint matrix is this one, that is 4 2 2 minus 5 0 5 1 minus 2 3 into the B matrix is the constant matrix, right? 4 0 2. Okay, so what is x? That is x, y, z. One by 10. So here we multiply these two matrices. So 4 4s are 16 plus 0 plus 4 and take this row and column, minus 20 plus 0 plus 10, and this is 4 plus 0 plus 6. So it gives 1 by 10 into, this is 20 and this is minus 10 and this is 10. If you take this 10 inside and divide it, we get 2 minus 1 1. Then if you equate this one to the right side, we get x equal to 2, y equal to minus 1 and z equal to 1. This is the solution. Alright, so x equal to 2, y equal to minus 1 and z equal to 1. And you know how to check the answer also, isn't it? So you substitute x equal to 2, y equal to minus 1 and z equal to 1 in any one of this equation, left hand side, you will get the right side, so that you can check your answer in that way. Okay, this is very important. Every year there used to be a one question from here for 6 mark, both in CBSE and NBSE. So please practice all the problems in your textbooks. Yeah. Today we learn how to solve the system of linear equations using matrix method. Otherwise we can say that using inverse of a matrix. In the next session we will be starting with relations and functions, that is chapter 1 in your textbook. Thank you.